Hello friends, in this video we are going to s- uh, do a simulation of a binary distillation column. So for this tutorial we have the problem statement. In this tutorial you will be a walk through a simple distillation process in Unisim, a binary liquid stream containing 70 mass percent benzene and the rest toluene, entering at 30 degrees Celsius and 1 atmospheric pressure, flowing at a rate of 1 kilomoles per second, will be distilled to ultra pure distillate and bottoms stream. We have provided a reflux ratio is equals to 3 and distillate flow rate is 2700 kilomoles per hour. So we have to simulate this distillation column for the following different cases. So for the case A, we have provided that run the column for this above specification process. B, use bottom flow rate 650 kilomoles per hour instead of the distillate flow rate. And C, objective is run the column for 80% benzene composition in the distillate instead of distillate flow rate. So we have to solve all these three cases. So first of all we will open Unisim, then start a new case. We'll first of all add the component. So we have benzene, so add benzene. Another component is toluene, so add toluene. Then close that component page, click on fluid package, add, select Ping Robinson, then close that button. Then you enter into a simulation environment, maximize this. Now from this object palette you select a distillation column and drop into a simulation environment. And either you can give a feed stream distillate and bottom by selecting the material stream, or you can directly double click on here and you can give the name. So distillation column, here is a feed stream. Then we have to select a total condenser, here is the distillate, then bottom. So we need a condenser and reboiler energy, so we'll write Q condenser, Q reboiler. After giving this input, you hit on next button so that next input expert will open. Here we have to give the condenser pressure, as we have mentioned that distillation column is operating at 1 atmospheric pressure. So put value 1 and select the proper unit, 1 atmosphere. Reboiler pressure is also same, it is given 1 atmosphere. So condenser pressure drop is already given, so we will not change it. Then hit on next button. Here it is given optional condenser temperature estimate, same for uh, optional stage temperature estimate. So we'll allow to Unisim to calculate it. So click on next button. Now here we have to give the liquid rate. We have given 2700 kilomoles per hour and reflux ratio is given, that is 3, right? Then after giving the input you click on this button done. Now still we have the message unconverge, right? Now to converge it, first of all we have to give the feed, we have to specify feed, right? So for that we'll click on this button. Temperature we have assigned, that is 30 degree Celsius and 1 atmospheric pressure, and flow rate is 1 kilomoles per second. So we'll put that value. temperature is 30 degrees Celsius, pressure is 1 atmospheric pressure, and flow rate is 1 kilomole per second. Now we have to give the composition, right, for feed stream. So for feed stream we have already mass fraction basis choose. So we'll write zero point 0.7 for benzene and zero point 0.3 for toluene. Then click OK. Here that feed stream is specified. Okay. Then uh, we have given all the values. Now to convert this, now by default this is, there is number of stages selected by Unisim is 10 and inlet stage is 5. So for this default selection we'll run the column by clicking run button. So for distillation column we have to always run the column for simulation separately. See here, now the column is converged. Now we'll see its effect. We'll click on worksheet. So this is about the feed stream. Distillate we have given flow rate is 2700 and bottoms is calculated here. Then you can see the composition for distillate. For benzene distillate is 0.9724 in distillate, and toluene is 0.027. Similarly fraction is given for bottoms also, right? Now if we want to change anything, for example for ultra pure we will use some more number of plates. So for example 23. So for 23 it will change. You can see the column is again unconverged. Now here inlet stage is already by default it's taken as a 11 number, so we'll take it as a 11. Or you can also change the inlet stage also. Then after making any changes we have to run that column again. Yes, that column is converged and we'll see what is the effect. Yes, we have definitely the composition of the distillate for benzene is increased by improving the number of stages, right? Now here is the first case. This is for the case 1, that is we have simulated the column for this above specification. Now suppose we want the bottom flow rate 650 instead of distillate flow rate 2700, right? So how to change, make a change. So for that we'll again double click on that and we'll select the spec button. In the design we'll select the spec button. By default there are 4 specs, right? So if you see reflux ratio, here is that reflux ratio is active because we have provided it. Distillate rate is also active, we have provided. Then these two will be inactive. These two will be inactive. Now we have to make inactive for the distillate rate, and we have to give the bottom product rate. So first of all, to avoid the over specified system, first of all we'll make this distillate rate inactive. So here the column is again unconverged. Now we have to give the bottom flow rate. So select it and make it active. Make it active. Now the message is highlighted. One or more specification in the column flow rate flow sheet are not fully defined. So click on OK button and specify it. So here name bottom product flow rate. Under the draw condition we have given bottom for the column 1, and for basis we have to select molar itself, and spec value we have to give, that is 650, right? 650. Okay, now you can see the column converge. Close this, run again, and you can check the effect. Now you see here the distillate flow rate, or check flow rate. Distillate flow rate is now changed. Bottom flow rate is 650 and distillate flow rate is also changed. Their composition is also changed. Their composition is also changed. There may be a change in the energy stream also, energy heat requirement, right? So for that you can see distillate now composition for benzene is 0.8951, which is decreased, right? So in this way we can see the change by making any input change, right? Now here we have solved the second one, right? that instead of distillate flow rate we have choose the bottom flow rate as a specification. Now the third case which we have to solve is run the column at 80% for 80% benzene composition in the distillate. Now for example we want this distillate product or bottom product for particular composition, so we have to simulate it for it, right? So for that, here we have again we'll click on the that specification and we'll find the specification. Now here only four specification has given, right? So we will add that specification, add button, and as we want a column component fraction, right? So here is a column component fraction, so we will click here and hit add spec button. Now here that is highlighted here, right? So here now composition of we have to find out the composition of the distillate, so it is not the stage, so it is a stream. So select the stream button and under this draw condition you will select distillate column, distillate column, right? So for basis we have given that mass fraction, so select mass fraction and spec value is 0 0.8, 0 0.8. Now we have to select the component, so we have to select the component benzene in distillate, right? Now we have make the changes. Now there are still converge button because we have not run the this column for the next or the new specs. So for that what we will do, we will uncheck this bottom production rate, right? We'll uncheck it, so it will unconverge. Then select component fraction and uh, make it active, make it active. So here we have already given about the component fraction, so it is automatically run. Now we'll see the effect what see here. Now here distillate of composition is 0.82 and material stream is also changed. Molar flow rate of distillate and bottoms are also changed. So in this way, by changing any composition or any quantity, we can see its effect by using this Unisim software. So this is the beauty of this software. Thank you.